Hello everybody, welcome to this video where I'm going to be walking you through step by step the process that I use to prepare large cosplay props for 3D printing. I'm going to be demoing today with a model of Sunraiser that I got from Sketchfab. I've credited the author in the description of the video. So what I'm first going to do is, as you can see, the author of this file has made several pieces. And that is really nice for modeling. But it's not really what we want for 3D printing. So the first thing we're going to do is go to File, Export, STL. You might not need to do this if you only have one single object, but I still like to do this, and I'm going to explain why. So you export that STL, and then I'm actually going to open Bamboo Studio. It's totally free, and it works really, really well with my 3D printer, so that is why it is my chosen slicer. So it's a very detailed model, which is pretty good. It might cause us some issues down the line, but the biggest thing that we want to focus on here is this error 480 non-manifold edges. Non-manifold edges will give you problems with 3D printing. They'll give you problems when you're slicing the part up to actually 3D print. So go ahead and repair that right now. Alright, the model is done repairing. So now you can export it from Bamboo Studio. Up here, File, Export, Export all objects as one STL. Go back to Blender, open a new file. So now we'll import that STL. There it is. Alright, so I'll do object, set origin, geometry to origin. That'll center it really nicely, as you can see there. You can use numpad 7 to look at it from a top view. Select it, drag this menu out here. So you can see the dimensions here. Now I know they say meters, but when Blender says meters, they really mean millimeters. So this sword should be about 2 meters long. So that's the size I'm going to scale it to. So I'm just going to scale up until I get to 2,000 millimeters, which is 2 meters. And then that makes it too big for the view window. So you click here on view, click on N and change that to 10,000. And now it doesn't disappear. So what I'm going to do now is set up my slicing tools in order to actually make the shape. So first I'm going to add a plane, and that plane is going to be 200 millimeters. And the reason for that is my printer has a 256 by 256 by 256 millimeter build volume. Now, if I size it this way, I'll be able to have 200 millimeters, so most of the space will be filled by the piece, and then I will be able to have a joint that sticks out. This is one of my section cutters, so I will also do geometry to origin on that so that it's centered nicely. Press G and then Y to move it in the Y-axis along this green arrow that you're seeing here. Then R, Z, to rotate around the Z-axis, you can see up there in the top right here. And then I'll type in 180, and it will flip it so that it faces that way. So you can see it's a little bit big right now. Now the way that my section cutters are designed, they work pretty well as long as their scale is not smaller than 0.5. So I can scale this down to about 0.75 by pressing S and then moving my mouse. And then that fits pretty nicely inside the hilt. You can see that would give me a decent amount of space on each side that will allow for strength, but also have a joint in there. So I usually like to have a joint pretty close to the cross guard. So I'm actually going to click on this plane, press G and then Y, and then move it up, and I'll line it up with that edge there. Then I'll get the section cutter, press G and then Y, and line it up right there as well. So you can see that lines up. And so now later on I'll be able to slice the model, and there will be a joint indented in this section, and I'll go ahead and walk you through the rest of that process. So you can duplicate objects by pressing Shift D, and then it automatically grabs it after you've duplicated it. So then I can just press Y and it will lock its movement to the Y-axis, and then I can once again do that. So I'm actually going to just make that one whole piece and that one whole piece. And then I'll come back and grab the section cutter and move it back there. And then I can duplicate the section cutter, D, Y, and put that there. And then I can print the sword from bottom to top, and the joints will be in place. And it looks like the section cutter is just slightly off. So I can just press G and then X, and then I can get that centered. If I really want to get it well, I can make the Sunraiser invisible, make the plane invisible, and then I can perfectly line this up with the axis here. So G, X. Now it should be perfect. And I'll do that with this one as well. And then once I line these up, I won't have to line the rest up because I'm just going to be duplicating them and then moving them in the same axis. So let's make those planes visible again. And one thing that I like to do to keep things organized is use collections. So I'm going to make a collection right now. And I'm going to call it planes. And then I'll move both of my planes in there. Then I'm going to make another collection. I'm going to call it cutters. And I'll move both of my cutters in there. So now I can continue. So another plane, Shift D, Y, drag and place. And I'm just going to go ahead and lay out the whole thing in planes, and then I'll do the section cutters next. Perfect. For this last one, I don't need to have another plane there at the end because this part won't have an additional joint sticking out at this side. So it's okay for it to have that little bit of overlap there, as long as it's not too significant. And I won't place planes here because I can see the edge of the plane that I need in order to get this part. So now to go through with the section cutters. And then you can press 3 to view from the side. So this is actually a really good side profile. This is about how I want my side profile to look. You want about that much thickness on either side of each cutter within the blade itself. So this is looking really excellent, actually. I'm very happy with this. And then to get these crossguard pieces, I'll do Shift D and then I'll move the section cutter over here. I'll press R, Z to lock it to the Z rotation, and then type 90. You do want the section cutter to be oriented this way. So you want the, here I'll make the model invisible here. So you want this to be oriented that way because that is a really easily supportable shape when you're 3D printing. Since I'm 3D printing vertically to get the most detail and make it the easiest to hide layer lines, I want this to be shaped that way relative to the print axis of it going vertically. This piece in the middle is going to be printed vertically. These crossguard pieces will be able to print vertically up from this cutoff line here. And I'll show you how to do that. Obviously right now it's a little bit too big, so we can scale it down a little bit more, down to 0.6. 0.6 is still okay, where it will still fit together nicely. If you go smaller than 0.5 on the scale though, you'll want to go down to like the section cutter quarter, because I've made 3 sizes of section cutters. The main section cutter for really big, thick things, section cutter small for most swords and great swords, and then the section cutter quarter, which is like a quarter of the size of the large one, and that's really good for getting really small details. So if I needed to go smaller than 0.5, I would go to section cutter quarter, but I don't need that. So then I'll go ahead and duplicate this, bring it over here, press R, Z 180 to flip it around at 180 degrees, and then I will grab it and line it up like so. And just like that, I have all of my cutters in place to slice up the sword. But this sword is going to be 2 meters long, so, or the joints alone is probably not going to cut it to keep it strong and stiff. So I've made another object, which is for a rod. So I'm going to use my 5/16 inch rod channel shape, and the default length I have on this is for a 6-foot rod. So that imports in really nicely centered already. And so then I'm just going to press G and then Y, and I will line it up. You want the rod to run through the pommel as much as possible because pommel is a really important part of actually holding and wielding a sword. So I really do want that pommel down there in that, or I want the rod to extend through the pommel as much as possible. Then you can see the rod extends through the rest of the sword. This pointed shape at the end makes it really easy to 3D print. That's a shape that's easy for the 3D printer to do internally. And then just to double check alignment, I'll go ahead and hide the sword itself. Let's look at how it lines up with the section cutters. if you have an issue where you can't really zoom in anymore, so I'm pressing the scroll wheel but it's not zooming, you can go to View, Frame Selected, and then that'll like reset your perspective so the Blender will let you zoom again. So looking at the section cutters, the rod looks pretty much not quite perfectly positioned. And you want it to be perfectly positioned relative to the section cutters. It doesn't have to be perfect relative to the sword. So I'll go ahead and hide the planes. I can do that just by hiding the entire planes collection there. And then I'll press 7 on the number pad to look at it from above, and then I'll take this and I'll press G, X, and then I'll just adjust it until that line is about as flat as possible. Then I'll press 3 to look at it from the side, press G, and then I'll move this time in the Z direction. Just get that as flat as possible again. Now you'll see if we look at the other section cutters, it lines up straight. That's what we want all the way through. And this is only a 5/16 inch rod, so that's not super ideal for a sword that's this big. One of the issues that might arise is this hilt is just a more, shall we say, petite hilt. So one thing you could do to mitigate that is to order a larger size rod. I have 5/16 as my default because they sell 5/16 fiberglass rods at Home Depot for like $5 a piece. So they're super cheap and super easy. But you could do something else. I definitely would want more reinforcement through the blade at least. So this part of the hilt is really thin, so it might be really difficult to get another rod through there. But I can put another rod through the blade, and that's exactly what I'm going to do. So I will press 7 to look at it from above, Shift D, duplicate this, and then I'll go ahead and do the conversion. So if you're calculating for your own rod, maybe one that I'm not giving an explanation for, what I like to do is I'll take 4 feet, so that's 48 inches, that's 25.4 millimeters, and that's 1219 millimeters. And then I like to give it about a 10 millimeter wiggle room. So we can go down here to the Y dimension, and I'll do 1229, and that will shorten it down. It still has the pointed shape on the end for the easy shape inside the printer, and now I have a 4-foot rod instead of a 6-foot. So now I've got my 4-foot rod. I will hide the sword again, and you can make it so that it overlaps with the section cutter like this. That's a pretty good shape. I can press G and then X, and I can move it closer. You just want to make sure that there is some wall thickness, so you don't just have the fiberglass sitting in there, and there is actual like solid plastic reinforcement between them. So that's pretty good there. And then if I make the sword visible again, you see that is contained inside the sword. We've got a decent amount of wall thickness there to keep it inside. Remember, this is a 2-meter object, so like that's a decent thickness. Not really something that I'd be too worried about right there. And then hide the sword again. We can just take this rod. If we look, actually I do want to look. So I will move it up a little bit. Press G and then Y. And just move it up. And the reason for that is because you want there to be some thickness at the base of the object. So then I'll duplicate this and then press X to move it only in the X-axis. Put it in about the same place, about the same amount of thickness, and just like that. So now I have 3 rods that run through the length of my blade, and I'm much more confident about that amount of stiffness. Just having one through the hilt is a little bit concerning, but I'm not super worried about it, as this is a more overall petite sword than the last 2-meter sword that I made, which is the Profane Greatsword from Dark Souls 3, so I think that this would work. And then I'll take the rods and I will make a new collection for them too. It's just easier to do it this way. Just like that. So now I've got the sword itself, cutters, rods. You don't need to really look at the planes anymore. If you want to, you can. Go ahead and save that. And this is what I would save as the pre-slice. So then I'll save a new file. So file save as again. And I'll change it to Sunraiser post slice. Now I'm going to show you guys how to use the Boolean difference modifier in Blender to cut shapes out of other shapes. So first, you want to select Sunraiser, and you'll go over here to this little wrench. That's the modifiers tab. So go to Add Modifier, then you choose Generate Boolean. Now, really important, you want to click off on this little monitor display. That will make it so that it doesn't display changes in real time, which is going to be really important because this is going to be a very computationally intense process. So you want to not have it updating in real time. You only want it to actually apply when you click the apply button. There's two different ways to do this. You can either do it by object, like so one object at a time, or you can do it by collection and do an entire collection. For example, the entire cutters collection or the entire rods collection. I'm going to show you how to do it one at a time because I find that to be more reliable. Blender runs out of memory sometimes if you try and do an entire collection at once. And if something goes wrong, then you have to redo it, the whole thing over again. Whereas if you do it one by one, if something goes wrong, you can tweak it and try to fix it before going on. So I'm going to leave it on object. And then the first thing that I'm going to do is cut out the center rod from the inside of the sword. So back on the sword, and then I have 5/16 rod channel shape, so I'll select that. I'm going to use the fast solver, so then I will save before applying it. Then I'll click on this little arrow and choose apply. So that just did its thing. Now if I press Z and go to wireframe, this is a very fine model, so there's a lot of detail in the mesh, so you can't see it super easily, but you can see there's now a channel shape inside there, and that is the result of that operator that we just applied. So then I'll just repeat that process. I'll go back, press Z, and then click solid again. Go back here, generate Boolean, hide it from the viewport. Then I'll select the next rod channel shape, fast, and apply. And we'll repeat the process yet again. So now we'll actually do the slicers. So it's the exact same process, Boolean, hide from the viewport, and then you'll select a slicer. So we'll do section cutter small. So section cutter small is this one right here. So do fast and apply. Let's see what happens. So now if I hide section cutter small, I see that there is a little sliver there. So that's what we want. So you can press tab. This goes into edit mode. So this lets you select pieces. So when you press L in edit mode, it will select all of the connected vertices. So you see when I pressed L, it selected this entire shape and it did not select any of the other shapes beyond it. And that's exactly what I want. So I'll press P and click selection. And that will separate what I've selected with L out into its own mesh. So now I have two objects instead of one. And that is exactly what I want. So then I can hide this other, and I can look at what I've got here, and I see exactly what I was looking for. And I now have a joint that I'll be able to use to assemble the sword together. I can check that on the other side as well. So hiding that piece, I can look here and see that there are the channels for the sword, and they're how we want it. That's good. So now you just have to pay attention to which one you're selecting and which section cutter you're selecting. So section cutter small 1 is here, so I will apply the difference modifier to this hilt piece. Make sure you hide it from the viewport again. And then I want section cutter small 1, fast, and boom, apply. So then I go into edit mode, press L, and boom, just like that. That's the right section, so I'll separate that. Press tab again to exit edit mode. I have two pieces. I can hide the section cutter, and then I can, once again, verify that everything is going together the way that I want, and it is looking beautiful. So then you just repeat this process all the way down the sword with each section cutter until you have all the separate pieces. So I'll skip ahead to that point. Alright, I've now got the sword divided up into sections. One thing that I thought of that I hadn't told you guys already, so you press A, right click and choose shade flat. That can make everything just look a little bit nicer and better polished, and it can help you better see some of the lines. You see it gives like a really neat look there, whereas if I click here and choose shade smooth, it looks really ugly. So So shade flat can be really useful for making sure that you're actually getting the right shapes. I did also have to use X-Acto for the cuts on the blade, otherwise they weren't properly separating. So that's just something you guys might need to keep in mind. You might need to use X-Acto if you're not getting proper separation with your cuts. So now you can see we've got pieces for the entire sword, and then I'm going to have to go through and I'm going to select each one. So I'm going to select the first piece that I want. I'm going to File, Export. You want to export it to an STL file. So I'll make a new folder here called Pieces. Go in here and I'll choose Sunraiser Hilt 1, and then make sure you check Selection Only. So that will only export the piece that you've selected as an STL. So I'll export that, and then you'll go through and repeat that process for each of these other pieces. So we'll go back to Bamboo Studio now that we've got all of our pieces. We're going to choose Import. We'll go into our pieces and select all of the STLs, and then open them. You're going to say no. You want them to be separate objects. So obviously you can't print all of these at once. You might be able to if you're really bold, but that's not what I'm going to try to do. So I'm going to add a couple of build plates. Start out with 6, see how far that gets us. Move this over there, see what auto does. Nope, not good. So the biggest thing with orienting these parts is you want them to maintain verticality so that these joints will fit together nicely. So I'm going to rotate this 90 degrees in X. Nope, other way. Negative 90 degrees in X. And there will be some rough spots from having to use supports down here, but those can be cleaned up in post. Then you just position that right there. I usually like to print 2 or 3 pieces at a time. I don't like to do more than that because if something does go wrong and fails, you've wasted a massive amount of filament if you're not standing there ready to go. That one did position a little bit better with auto. So I've got those 2 pieces. They're positioned. It looks like this actually is thick enough that you could run a rod all the way through and it would work pretty well. So, lesson learned, I've made a mistake. And then if you really wanted to, you could also find the guard pieces, and you could print those on this plate too, since they're smaller. And then you've got those positioned there. Then take this piece. This one's going to be kind of a doozy. Let's see what it says for auto. Oh, nice. It auto-oriented nicely. So we'll take this over here and position it. And it's just a little bit big, so we'll rotate it in the Z 45 degrees and print it diagonally. And then just like that, there's plenty of space for it. So that's one that I would definitely print all on its own. You will use some material up in support, but it will be worth it because it'll be easy to remove those supports. If you have the if I had the base of the crossguard too close to the build plate, removing those supports would be an absolute pain. So this is a better way to go in my opinion. And you can select them all at once. I just tend not to because sometimes parts will get oriented weirdly when you select auto, so I like to separate them out, as you can see. So I have my blade 1, my blade 2, and my blade 3, so I'll put all those on one build plate. Then I'll put the other 4 pieces on another. So you can organize them as you will, but I think this is a pretty good setup. So then you can have global settings you can affect everything with. So I'm going to set the default to 5 wall loops. That's going to add a decent amount of weight, but it will also add a lot of stiffness. And then you want to use either gyroid or 3D honeycomb or adaptive cubic infill. I'll just use gyroid for this. That's a good go-to. And then once you've got the global settings set up, you can go into objects and you can change the settings per object. You want as much of the weight of the sword as possible to be in the hilt. Obviously, since we have a rod that starts kind of at the exit of the hilt, that's not exactly going to work out, but it is still a good goal. So we're going to have the strongest parts are going to be at the hilt and at the base of the blade. So this cross guard right here, you're going to leave the wall loops and the infill density the same on those. The guard pieces don't need to be very strong, so you can just change those down to like 3 wall loops and 10% infill, and that will be fine for those. Then as you go up the blade, you'll want to correspondingly decrease the strength. So for blade 2, blade 1, I'll leave it at I'll go down to 4 wall loops for blade 1, likewise for blade 2, 4, blade 3, 4. You don't want to decrease the infill a whole lot, because the infill is what keeps the rods from moving around internally, and so you kind of want to leave that. So 4, I'll do 4 wall loops. Actually, I'll go down to 3. For blade 5, go down to 3 with 15% infill. Blade 6, the 4-foot rods have an end in blade 6. So blade 6, it's not going to have a lot of stress. You can go down to 3 wall loops, and we can actually drop the infill down to 10%. And then for the tip, we'll do 2 wall loops and 10% infill. And actually, I'm going to come back to the cross guard. I'm going to do 2 wall loops on those as well. So then you can slice each plate, and you can figure out how much filament you're going to use. Let me go ahead and save this project. Support. And I'm going to do tree auto. That usually works great. Brims, we'll do outer brims. A brim is just a flat piece of material around the edge that keeps it from coming off. This is PETG, so it sticks to itself quite well and to the build plate pretty well, so I'm not super worried about it, but we'll go ahead and reslice now. Alright, that slice did take some time. There we have it. So it would take 257 grams to print out the hilt and those pieces. The total, if we go to the all plate stats now, the total amount of filament would be 1,221 grams. That is not bad at all, and 1,174 of those would be in the model. So that means that the sword would come out to weigh about 2.5 pounds. That's not bad at all, I don't think. And so that's not a super crazy filament cost either. I mean, I can get 2 full rolls of Sunraiser PETG from Amazon for about $23, so not too bad, plus the about $10 that you'd spend on fiberglass rods, and you could make this sword for the low price of about $30 for a 2-meter long, awesome looking shard blade from the Cosmere. So after that, it's just a matter of hitting print, using PETG, and letting your printer do the magic. I really hope you guys enjoyed this video. If you want to see me actually make Sunraiser physically, please let me know, leave a comment, and we will have to get on that. And I hope you enjoyed. Let me know if you have any feedback. Show me the things that you make, please. I'd love to see the things that you guys come up with. And I hope you enjoyed this video.